At Simcenter Flomaster, we have created an executable digital twin to demonstrate some of our latest capabilities. This is an extremely important development as it provides a full fidelity solution that runs in real time and solves for every time step. In doing so, we're able to capture all of the complex thermofluid capabilities such as elasticity and transient effect. This adds significant additional value to your model as the Simcenter Flomaster executable digital twin runs alongside your plant and provides many benefits such as virtual sensing, leak detection, or error investigation and diagnostics, to name just a few. Let's have a look at how we achieve this. A couple of important new components have been introduced in Simcenter Flomaster 2021.2 in order to achieve this. The first is the OPCUA client reader, and the second is the OPCUA client writer. These enable you to connect to an OPCUA server and both read values from it and then write to it. This is achieved quite simply by setting a server URL, a node ID and a node name to log in to your server instance. Further to this, a server sampling interval also needs to be set, and in most cases this should be set to 1, as this works in conjunction with our real-time controller in order to set the real-time interval of our Flomaster model. We can see that these components have been used in several places in our Flomaster demonstrator model. Here you can see that they're used to read the flow rate value from the server into the Flomaster model and also used to control valve positions. We then gain additional values on each of the lines as a flow rate on line 1, 2 and 3. These communicate with the server and pass values both to and from it, and we can see here that we've very simply set it up with the data that we've already discussed. One of the key demonstratable capabilities of the test rig is its ability to provide virtual sensing information. This is useful when you're operating at extremes of temperature or flow, and adding a sensor would disrupt this. It could also simply be prohibitively expensive to install a sensor, or maybe it's just impossible. By using virtual sensing, we can overcome all of these obstacles. This is achieved by coupling the Simcenter Flomaster model to the hardware through an executable digital twin. Sensor data is passed to the Simcenter Flomaster model, and the simulation solves for these conditions and then passes virtual sensor data back to the plant. This can be displayed on a HMI or used to calculate additional values, and to a user or plant operator there is no discernible difference between a physical sensor and a soft sensor. Simcenter Flomaster can be used to connect your plants in the same way as this demonstrator to provide virtual sensing data to your processes. We can see here both the Simcenter Flomaster model running in the background, along with the HMI running on our experimental testing facility. In this case, you can see the flow rate coming in on the Flomaster model, noted by the red arrows, and then the flow splits into two of the main flow paths on line 1 and 2. On the HMI we can see all of the sensor data available, and we can see that we have 3 blue sensors on the schematic. These are virtual values simulated by Flomaster, and they've simply been coloured for easy identification. We can see that in lines 1 and 2 a flow rate is present, and these are calculated using the Simcenter Flomaster model through virtual sensing, and to an operator there'd be no discernible difference between the real flow meter on the left and the 2 virtual flow meters on the right. This shows how powerful virtual sensing can be, as an operator wouldn't be able to notice the difference and would gain significant additional value and understanding of their plant by having a Simcenter Flomaster executable digital twin running in real time in the background. Thank you for joining me and having a look at our executable digital twin solution. If you have any further questions or want more additional information, please reach out to me.